Hi everyone, I'm Marc Bates, a metabolic health coach, and this is another in my question and answer series. So, the question was, you mentioned that wheat germ, agglutinin, can either stimulate or block insulin activity depending on concentration. This dual mechanism seems particularly insidious for metabolic health. Can you walk me through exactly how this concentration dependent effect works at the cellular level and why this makes lectin exposure potentially more damaging than a straightforward insulin antagonist? That's a wonderful question. So here we go. So first, what is WGA? WGA is wheat germ agglutinin and it's a lectin, a carbohydrate binding protein found in whole wheat. It's especially concentrated in the wheat germ. WGA is highly resistant to digestion and heat, meaning that even after cooking, it can remain biologically active in the gut. That makes it dangerous. How WGA interacts with insulin receptors. So, WGA has structural similarity to insulin in its ability to bind the insulin receptor, IR, on cell surfaces, particularly on adipocyte, fat cells, and myocyte, muscle cells. But here's the twist. At low concentrations, WGA mimics insulin, binds to the insulin receptor, and activates downstream signaling pathways such as the PI3K, AKT, GLUT4 translocation, which means increased glucose uptake, right? So it actually makes it think like it's increasing the glucose uptake. Inhibition of lipolysis, which is fat breakdown, so it blocks the ability to burn fat, and the activation of lipogenesis, which is fat storage. So eating wheat actually makes you fat, and there's a reason why. Okay? The result, mild pseudo-insulin activity leading to inappropriate nutrient storage. Right? You're not burning the nutrients, you're actually turning it into fat. This is problematic because it can drive anabolic fat building, signaling even when insulin levels should be low, contributing to hyperinsulinemia and fat again. Okay? At high levels, it occupies or saturates insulin receptors without fully activating them, preventing natural insulin from binding effectively and causing insulin resistance. And that in itself is a bad thing. So why is this more damaging than a simple antagonist? A straightforward insulin antagonist, like a drug or toxin that blocks the receptor, right, has predictable pharmacodynamics, which is that we know how it works. It inhibits insulin activity in a dose-dependent linear fashion. In contrast, WGA's biphasic dual effect creates erratic signaling. Some cells receive a mix of false go and block signals at the same time. Adaptive confusion. The metabolic machinery downregulates insulin sensitivity in response to overstimulation, low-dose mimicry, and antagonism, high-dose interference. Widespread impact. Because WGA is absorbed in small amounts and accumulates in tissues, its systematic metabolic effects are not limited to the gut. It affects your entire body. This metabolic chaos can accelerate adipose tissue inflammation, inflamed fat tissues. Yes, your fat tissues can get inflamed, which impairs the entire body. Impaired glucose uptake, which means that you're not getting the energy from the glucose you're eating. Go see my video on your cells are starving. Okay. Chronic hyperinsulinemia, that's beta cell fatigues. Your pancreas gets tired of just producing as much insulin as it takes to get things to work. And downstream progression towards type 2 diabetes. Yeah, eating wheat can help make you a type 2 diabetic. Okay, cellular level consequences. GLUT4 dysfunction. Transporter proteins responsible for glucose entry into muscle fat cells become desensitized. So those GLUT4s don't work as well, which is also a problem because GLUT4 is how vitamin C gets into the cells, because vitamin C looks very much like glucose. That affects the cell as well. mTOR SCK overactivation. These growth signals can be stimulated by insulin mimetics like WGA, contributing to fat accumulation and insulin resistance. It keeps piling on. Reactive oxygen species, ROSs. Abnormal receptor signaling increases oxidative stress in mitochondria, which break down the mitochondria, reduce the energy. You want to know why you don't feel healthy and you don't feel energetic? Cytokine production. WGA can activate macrophages, increase TNF alpha and IL-6. We talked about that earlier in other videos, which further disrupt insulin signaling. Boy, who thought eating whole wheat was going to be that unhealthy? Okay, so bottom line, why this matters. A dose-dependent dualism of WGA turns it into a metabolic Trojan horse. At low doses, it tricks the body into thinking insulin is acting when it's not. At high doses, it prevents real insulin from working, so you're in full insulin resistance at that point. This makes it more dangerous than a simple inhibitor, especially in a world where people regularly consume high amounts of whole wheat and other lectin-rich grains. You didn't know that much about wheat, did you? Okay. Thank you for watching. Please, once again, like, subscribe, click the bell button if you want to be notified. We do thank you very much. Bye.